Algebra 2 Cram, New York State Algebra 2 Regents, but no worries, this is a common core Cram session, so it can be used for any Algebra 2 course throughout the country. So shout out to Tennessee, Illinois, the South Carolina, Georgia, Texas, even Rhode Island. Thanks for the support, as well as any Algebra 2 course throughout the world. Shout out to Brazil, Russia, Afghanistan. We see you, okay? So, rational expressions, question 9, solve an absolute value equation. Set notation. We'll be discussing set notation, an absolute value equation, factoring polynomials, polynomial roots, solution sets, the zero product property, checking for extraneous roots, and putting a second order polynomial equation into standard form. If I could stick every single Algebra 2 student with a syringe containing a healthy dose of eye-open awareness of their inner mathematical genius, I definitely would. So inbox me at memedicine@gmail.com to get your healthy dose by ordering and purchasing the complete Algebra 2 Cram session. Be sure to spread the word to your friends, classmates, colleagues, and peers who are taking Algebra 2 with you as well. Tell them to inbox me at memedicine@gmail.com so that they too can get their healthy dose. Let's delve into the concept. Question 9, absolute value equation. What is the solution set of the absolute value of x squared minus 2x is equivalent to 3x minus 6? Is it going to be A? Okay, I'm really excited for this part. We're going to discuss solution set notation really briefly. And technically, there should be an x followed by a vertical bar like this written here, but when it's not written, it's implied. So this reads the set of x, and if there were a vertical divider there, it would be read such that, not to be confused with the absolute value bracket, such that x is equivalent to 2, and the comma is read such that x is equivalent to plus or minus or positive or negative 3. Is the correct answer going to be B, the set of x, such that x is equals 2? Would it be C, the set of x, such that x is equivalent to positive or negative 3? Or is the correct answer choice D, the set of x, such that x is equal to 2, such that x is equal to 3? Definitely press pause if you need to, and I'll give you a moment to think. Okay, so hopefully by now you were able to press pause and come up with an answer. If not, that's fine. Let's do this together. To solve this or any absolute value equation algebraically, what we're going to have to do is write two separate equations in order to eliminate the absolute value vertical brackets. The rule of thumb for solving these two different cases is this. For the first case, we're going to assume everything in the absolute value brackets is already positive, and then we're going to remove these brackets and solve, okay? So our first case should wind up looking like this. X squared minus 2x equals 3x minus 6. In the second case, we assume that everything inside the absolute value brackets is negated. That is, we're going to multiply everything inside the bracket by -1, and then remove the brackets and then solve. So our second case should look like this. Negative x squared minus 2x equals 3x minus 6. We'll just take this one step further and distribute this negative sign, or an implied -1. We end up with x squared plus 2x, well, negative x squared plus 2x equals 3x minus 6, okay? Now we're going to solve for both cases by writing them in standard form, that is carrying all the terms over to the left-hand side and setting the right-hand side equivalent to 0. And after we're in standard form, we're going to solve for the roots of the equation, okay? Whenever you hear roots in this context, it's just where the equation will equal 0 or where you'll have a y output of 0 after inputting in x, okay? All right, so let's go ahead and do this. So our first case will end up looking like this because we subtract 3x and add 6x to both 6, not 6x to both sides of the equation, and we wind up with x squared minus 5x plus 6, and we're in standard form with our highest degree polynomial written first, the first order term written second, and the constant written third, okay? Or in our second case, what we'll end up with is x squared plus x minus 6, again, after subtracting 3x and adding 6 to both sides of the equation, thus setting it equal to 0. All right, now we're going to factor our polynomials. So since we have second order polynomials, we're going to have to open up two set of parentheses with a first degree term of x. And we're going to have to find the constants that when you multiply them, you get the constant term positive 6, but when you add them, you get this leading coefficient term of negative 5. So our factors should look like this. X minus 2 times x minus 3 is equivalent to 0. We're going to do the same for our second case. We open up two sets of parentheses because we have to have a first degree term of x that are multiplied in order to get this x squared. And then we look at the constant term, and we have to find two numbers that when we multiply them, we get negative 6, but when we add them, we get 1. Nothing written in front of this x is an implied leading coefficient of 1, and those two numbers would be negative 2 and positive 3. Okay, now we're going to use our zero product property because we're at the exact point of solving for our roots, or where y equals 0, or where the equation is equal to 0. And the zero product property states that if we have two factors that multiply to yield 0, either one of them are going to be 0 or both can be 0. Okay, we're just going to assume that both is equal to 0, and we're going to check to see if we're right in a little bit. So according to this, if we set both factors equivalent to 0, x is equivalent to 2, or x is equivalent to 3. That's because we would have to add rather 2 on both sides of the equal sign to yield 2, or we would have to add 3 on both sides of the equal sign to yield 3. Okay, we split these up into two separate equations, just in case you're wondering how we got from here to there. Or in our second case, we wind up with x is equivalent to 2, or x is equivalent to negative 3. All right, we also use the zero product property. I hope you're still with me. This is almost over. Now we're going to check our candidate solutions in the original equation for extraneous roots, because our zero product property is not foolproof. And you're probably wondering, okay, like, what's an extraneous root? Well, we have this absolute value equation, and we did all this work, okay, and we came up with three distinct roots: 2, 3, and negative 3. If we put the candidate solutions into this original equation, and the left-hand side is equivalent to the right-hand side, that means they're true roots. But if we put any of them into the original equation and the right-hand side doesn't equal the left-hand side, vice versa, they're extraneous, okay? That means our guess for both factors yielding a 0 is going to be false. And these extraneous roots often occur whenever you have squaring going on in the original equation, which we do have here, or whenever you're raising an exponent, raising a base to an even number exponent. That's when you'll get extraneous roots. Okay, so now checking the candidate solutions from least to greatest. We're first going to check x is equivalent to negative 3, so we input negative 3 into our original equation. And so we have the absolute value of negative 3 squared minus 2 times negative 3 equals negative 3 minus 6. So we get 9 minus a negative 6 is going to be 15. And then on this side, we get 3 times negative 3, that's negative 9, minus 6, that's negative 15. So basically, we get that 15 is equal to negative 15. And this is not wrong. I mean, this is not correct. Therefore, negative 3 is an extraneous root. It's not a part of the solution set. It doesn't check. Now, going up in value, we're going to check 2. So when we check for x being equivalent to 2, we input it in the original equation, and when we analyze this, we get basically 4 minus 4 is equivalent to 0, and on this side we get 3 times 2, that's 6, minus 6 is equivalent to 0, so we get 0 equals 0, and yes, that does check. Therefore, 2 is in fact a true root. It's not extraneous. Now, last but not least, we're going to check our value when x is equivalent to 3, okay? And after plugging 3 into the original equation, on this side we get 3 squared, that's 9, minus 6, that's going to be 3, and we get 9 minus 6 on the other side as well. So we get that 3 is equivalent to 3. This does in fact check. 3 is a true root. That means that the correct solution set is going to be x, such that x is equivalent to 2, such that x is equivalent to 3. The correct answer choice is D. Okay, and one more thing, this absolute value equation could have been solved really fast if you know how to leverage the graphing features on your graphing calculator. Okay, so basically what we would normally do is use our calculator to graph the absolute value of x squared minus 2x equals 3x minus 6. And what we would do is we would input each side of the equation into our graphing calculator as separate equations, and then, find out where they intersect. But this doesn't yield an easy to read graph. All right, it's a little confusing. So the alternative and the best thing is to set this entire equation equivalent to 0 by subtracting 3x and adding 6. Okay, this is a common practice that you're going to do if you want to solve absolute value equations graphically using your graphing calculator. And then what we do is basically find out where this equation is going to cross the y-axis, because cross the x-axis, because crossing the x-axis is the same thing as saying that the overall equation is equivalent to 0 or y is equivalent to 0. Okay, so yeah, doing this gives a much easier to read graph, and we see that the graph crosses the x-axis at, well, this is 1, here's 2, and also 3. You can even do a 0 calc check by using the calculation feature on your graphing calculator. Okay, so again, we reconfirm that there are solutions at x equals 2 and x equals 3. So the correct answer choice, once more, is going to be the set of x such that x is equivalent to 2, such that x is equivalent to 3. Thanks for tuning in.